Have you ever wondered how neural networks actually learn? We keep hearing about training a model or tuning weights, but what's really happening behind the scenes? The magic lies in an algorithm called backpropagation, the backbone of deep learning. In this video, we'll break it down step by step, from intuition to math, in the simplest way possible. Backpropagation, short for backward propagation of errors, is the method neural networks use to update their weights. Think of it like this. You make a prediction, compare it with the correct answer, calculate the error, and then send that error backward through the network to figure out which weights should be adjusted and by how much. In other words, backpropagation is the algorithm that tells your network, hey, you messed up here, so tweak these weights a little to improve next time. Let's quickly see the learning process of a neural network in 4 steps. 1. Forward pass. Input goes through the network and we get a prediction. 2. Loss calculation. We compare the prediction with the actual label. 3. Backward cast. We calculate how much each weight contributed to the error. 4. Weight update. We adjust the weights slightly to reduce the error. This cycle repeats thousands or even millions of times until the network becomes accurate. Backpropagation is step number 3, the brain of the learning process. Imagine you're throwing darts at a board. At first, your aim is off. After each throw, you check where it landed and adjust your aim a little bit. Over time, your throws get closer to the bullseye. That's exactly what backpropagation does. It measures how far off your predictions are, then uses that information to make small corrections to your aim, which in this case are the weights of the neural network. Now let's get a bit mathematical. At the heart of backpropagation is calculus, specifically the chain rule. The chain rule helps us calculate how a change in one variable affects another through a sequence of functions. Since a neural network is basically a series of functions stacked on top of each other, linear combinations followed by activation functions, we use the chain rule to compute derivatives layer by layer. For each weight W, we want to know derivative of loss with respect to W. This derivative tells us how sensitive the loss is to that weight. Backpropagation systematically computes these gradients from the output layer back to the input layer. Let's walk through a simple example. Suppose we have a neural network with one input layer, one hidden layer with activation, and one output neuron. First, forward pass. We calculate the weighted sums and pass them through activation functions, producing an output. Second, loss calculation. We compare the output with the true label using mean squared error. Third, backward pass. We compute the gradient of the loss with respect to the output, then propagate it backward layer by layer using the chain rule. Fourth, weight update. We adjust the weights using gradient descent. Weight equals weight minus learning rate times gradient. Backpropagation is powerful because it efficiently calculates gradients for networks with many layers. Without it, training deep neural networks would be nearly impossible. Instead of brute force guessing, backpropagation smartly applies the chain rule, ensuring each weight gets updated in the right direction to minimize error. Of course, backpropagation isn't perfect. It can suffer from the vanishing gradient problem, where gradients become extremely small in deep networks, slowing learning. Or the exploding gradient problem, where values blow up and destabilize training. Modern techniques like ReLU activations, batch normalization, residual connections, and optimizers like Atom help fix these issues, but at the core, backpropagation remains the same. So, to wrap it up, backpropagation is the algorithm that allows neural networks to learn by sending errors backward and updating weights using gradients. It's not magic. It's just calculus and the chain rule working together behind the scenes. If you found this explanation useful, don't forget to like the video, subscribe for more AI deep dives, and let me know in the comments which concept you'd like me to break down next. Thanks for watching, and I'll see you in the next one.